Cryptocurrency mining is an energy-intensive process that requires optimal environmental conditions to ensure efficiency, longevity, and profitability. The best environment for crypto mining rigs is a combination of several factors, including temperature control, ventilation, humidity regulation, electrical infrastructure, security, and legal compliance. Achieving the right balance between these elements can significantly impact the overall mining performance and prevent potential risks such as overheating, hardware failure, or excessive electricity costs. 1. Temperature and cooling systems. Temperature regulation is one of the most critical aspects of a mining rig environment. Mining hardware, such as ASICs, application-specific integrated circuits, and GPUs, graphics processing units, generate substantial amounts of heat during operation. If not properly managed, high temperatures can reduce efficiency, damage components, and shorten the lifespan of the equipment. The ideal temperature range for mining rigs is between 15 degrees to 25 degrees, 59 degrees to 77 degrees. To maintain optimal temperatures, several cooling methods can be implemented. Air cooling. This is the most common method, involving the use of high-speed industrial fans and exhaust systems to circulate air and dissipate heat. Proper airflow management is necessary to prevent hotspots. Liquid cooling. This method uses water blocks or specialized coolant liquids to absorb heat from mining components. Liquid cooling is more efficient than air cooling, but requires a higher initial investment. Immersion. Cooling. Advanced setups involve submerging mining rigs in a dielectric coolant, which efficiently dissipates heat and reduces noise. This method is expensive, but highly effective for large-scale mining operations. Climate control systems. In hotter regions, air conditioning units or evaporative cooling systems may be necessary to keep temperatures within acceptable limits. 2. Proper ventilation and airflow management. Efficient airflow is essential to ensure heat is expelled and fresh air is constantly introduced into the mining area. Poor ventilation can lead to heat buildup, reducing mining efficiency and increasing the risk of hardware failure. Mining farms or home setups should incorporate the following ventilation strategies: intake and exhaust systems, creating an airflow cycle where cool air enters from one side and hot air exits from another side prevents heat accumulation. Ducting systems. Using air ducts to direct hot air outside the mining space can improve efficiency. High-capacity fans. Installing industrial-grade fans to push hot air out and bring in fresh air is a cost-effective ventilation solution. Optimized rig placement. Mining rigs should be placed with adequate spacing between units to allow air circulation. 3. Humidity. Regulation. Humidity control is often overlooked but plays a significant role in mining rig performance. High humidity can lead to condensation, causing short circuits and rusting of electronic components, while low humidity increases static electricity risks. The ideal humidity range for mining rigs is 40% to 60%. To regulate humidity levels, dehumidifiers. These devices remove excess moisture from the air, preventing condensation and corrosion. Humidifiers. In dry climates, adding humidity to the air reduces static buildup that can damage electronic components. Silica gel packs. Placing silica gel near mining rigs absorbs moisture and protects against humidity fluctuations. 4. Electrical infrastructure and power supply. Crypto mining is power-intensive, requiring a stable and robust electrical infrastructure. The efficiency and safety of a mining operation depend on the following factors. Dedicated circuitry. Mining rigs should be connected to dedicated electrical circuits to prevent overloads and reduce fire hazards. High-efficiency power supply units, PSUs. Using 80+ gold or platinum-rated PSUs ensures energy efficiency and stable power delivery. Voltage stabilizers and surge protectors. These devices protect mining rigs from voltage fluctuations and electrical surges, reducing the risk of hardware damage. Backup power solutions. Uninterruptible power supplies, UPS, and generators ensure mining rigs continue operating during power outages. Energy-efficient configuration. Running mining rigs at optimal power settings reduces electricity consumption and maximizes profits. 5. Noise reduction and soundproofing. Mining rigs produce substantial noise due to high-speed fans and power-intensive operations. Noise pollution can be a concern in residential areas or large-scale mining farms. To minimize noise levels, soundproof enclosures, encasing mining rigs in soundproof boxes or cabinets reduces noise output. Low-noise fans. Using high-quality, low-noise fans minimizes unnecessary sound while maintaining airflow. Strategic rig placement. Positioning mining rigs away from living spaces or sound-sensitive areas reduces noise disturbance. 6. Security and safety measures. Mining equipment is expensive and requires proper security measures to prevent theft, cyber attacks, and physical damage. Effective security strategies include physical security, installing surveillance cameras, access controls, and alarm systems ensures mining rigs are safe from theft or unauthorized access. Fire safety precautions. Mining rigs generate heat, increasing fire hazards. Using fire-resistant materials, installing smoke detectors, and keeping fire extinguishers nearby enhances safety. Cybersecurity measures. Protecting mining setups from hacking attempts involves using firewalls, VPNs, two-factor authentication, 2FA, and encrypted wallets, redundant backup systems. Data loss due to power failures or cyber attacks can be mitigated by keeping backups of mining configurations and wallet information. 7. Ideal mining location and environmental factors. The geographical location of a mining setup influences energy costs, climate conditions, and legal considerations. Choosing the best location involves access to cheap electricity. Countries or regions with low electricity rates, such as Iceland, Canada, Russia, or parts of the US, are preferable for large-scale mining. Cool climate. Naturally cooler environments reduce the need for artificial cooling, saving on operational costs. Renewable energy integration. Utilizing hydroelectric, solar, or wind power reduces electricity costs and promotes sustainability. Legal and regulatory considerations. Some regions have restrictions on cryptocurrency mining due to high energy consumption. Ensuring compliance with local regulations prevents legal issues. 8. Internet connectivity and network stability. Stable internet connectivity is essential for mining efficiency, as delays in communication between mining rigs and mining pools can lead to revenue loss. The best internet setup includes high-speed internet, fiber or broadband. Low latency and high bandwidth connections ensure mining data is transmitted quickly. Redundant internet connections. Having a secondary internet provider prevents downtime in case of network failures. Wired connections, Ethernet. Wired networks offer more stability than Wi-Fi, reducing the risk of connection drops. VPN for security. Using a VPN protects mining operations from DDoS attacks and unauthorized access. 9. Scalability and future expansion. For those planning to expand mining operations, designing a scalable setup is crucial. Factors to consider for scalability include modular rig configurations. Using stackable racks and shelves allows for easy expansion without compromising airflow. Efficient cable.